Allow to welcome in our mathematics paper 2 second lecture. We have seen the definition of Laplace transform, which is nothing but the integral of the function e to the power minus st f of t. That is Laplace of f of t equal to integration 0 to infinity e to the power minus st f of t dt. Now we solve some examples on Laplace transform. Find Laplace of sin hat and second Laplace of cos hat. First we find Laplace of sin hat. We use the formula for sin hat, which is e to the power at minus e to the power minus at divided by 2. Then by linearity property of Laplace transform, we separate this two Laplace transform 1 by 2 into Laplace of e to the power at minus Laplace of e to the power minus at. Then we use the formula of Laplace of e to the power at, that is 1 upon s minus a. Therefore we have 1 by 2 into 1 upon s minus a minus 1 upon s minus of minus a, that is s plus a. Then we solve this by taking the LCM. 1 by 2 into the LCM s minus a into s plus a. Then by cross we have s plus a minus s plus a. S cancels. Then we have twice of a. Twice a divided by s minus a into s plus a. We have s square minus a square. Therefore we write 2 times s square minus a square. 2 cancels. Therefore we have a upon s square minus a square. Therefore Laplace of sin hat equal to a upon s square plus a square, where s is positive. So which is the Laplace of sin hat. Then we see the second example. Laplace of cos hat. Now we use the formula for cos hat, which is given by e to the power at plus e to the power minus at divided by 2. Again we separate the Laplace transform of the two functions by linearity property. We have here plus sign. Then use the formula Laplace of e to the power at equal to 1 upon s minus a. Therefore we have 1 by 2 times 1 upon s minus a plus 1 upon s minus of minus plus s plus a. Then we take the LCM, that is s minus a into s plus a. Then by cross we have s plus a plus s minus a. Here a minus a cancel, therefore we have twice s divided by 2 times in the denominator s minus a into s plus a. By the formula a minus b into a plus b, a square minus b square. Therefore we have s square minus a square. Therefore s divided by s square minus a square. Therefore we obtain the Laplace of cos of hat equal to s divided by s square minus a square. Up till now we have seen the Laplace of some linearity functions with the linearity property of Laplace transform. Therefore we list all these formulae of Laplace transform. The first formula, Laplace of 1, we have 1 by s. Second formula, Laplace of t equal to 1 by s square. Third, Laplace of t to the power n factorial divided by s to the power n plus 1. where n is equal to 0, 1, 2 and so on. And second formula for Laplace of t to the power n is gamma n plus 1 divided by s to the power n plus 1, where n is not equal to 0 and not a negative integer. Not a negative integer. Then fourth, Laplace of e to the power at. What is this? We have seen 1 upon s minus a. Here s is greater than a. Then fifth, Laplace of sin at. It is given by a divided by s square plus a square. Sixth, Laplace of cos at. It is given by s divided by s square plus a square. If there is Laplace of sine, then there is a constant in the numerator. Remember this. And if there is Laplace of cos function, then there is s in the numerator. 7. Laplace of sin at equal to a divided by s square minus a square. And lastly, Laplace of cos at. It is given by s divided by s square minus a square. These are the 8 formulae of Laplace transform. Remember this, which are useful for solving the examples on Laplace transform. Then we take some additional examples of Laplace transformation. Example, find Laplace transform of t square plus at plus b. Solution. Laplace of t square plus at plus b. We separate the Laplace of all the three terms by linearity property. Therefore, Laplace of t square, a is constant taking outside the bracket, a into Laplace of t, b is constant, we write b into 1, therefore b into Laplace of 1. Then use the formula for Laplace of t to the power n. We have Laplace of t to the power n given by n factorial divided by s to the power n plus 1. Therefore, we have n equal to 2 factorial divided by s to the power 2 plus 1 plus a into Laplace of t. We have 1 upon s square, and Laplace of 1 we have 1 by s. Therefore, 2 factorial is 2 divided by s cube plus a divided by s square plus b by s. To simplify, we take common 1 upon s cube. Therefore, we have here 2 plus as plus b square, which is the required transform of Laplace of t square plus at plus b. Then we see the second example. Laplace of 3t square plus twice e to the power t plus sin h 3t plus 5 cos 4t. Again, we separate the Laplace of each functions by using the linearity property of Laplace transformation. Therefore, Laplace of 3t square minus twice e to the power t plus sin x 3t plus 5 cos 4t. 3 is constant, take outside. Laplace of t square. 2 is constant. Laplace of e to the power t plus Laplace of sin x 3t. 5 is constant, take outside. Laplace of cos of 4t. Then use the formula for Laplace of t to the power n, which is given by n factorial divided by s to the power n plus 1. Here n equal to 2, therefore we have 3 into n equal to 2, therefore n factorial, that is 2 factorial divided by s to the power 2 plus 1 minus 2 into Laplace of e to the power t. It is, we know that Laplace of e to the power at 1 upon s minus a equal to 1 here, coefficient of t is 1, therefore 1 divided by s minus 1 plus Laplace of sin h at t. You know the Laplace of sin h at t, that is a divided by s square minus a square. Here a equal to 3, therefore we have 3 divided by s square minus 3 square plus 5 into now Laplace of cos at, you know that s divided by s square plus a square. A equal to 4, therefore s divided by s square plus 4 square. Therefore we have this 2 factorial is 2, 2 into 6, 6 divided by s cube minus 2 divided by s minus 1 plus 3 divided by s square minus 9 plus 5s divided by s square plus 16, which is the required Laplace transform of the given function. Then we see the next example, example 3. Find the Laplace of sin wt plus alpha. Sin wt plus alpha. Now here we use the formula of sin of a plus b. You know the formula for sin of a plus b. Sin of a plus b equal to sin a cos b plus cos a sin b. A equal to omega t and p equal to alpha. Therefore we use the formula for solving this example. Hence Laplace of sin of wt plus alpha equal to Laplace of, use the formula, sin a sin wt cos of b, that is cos of alpha, plus cos a, that is cos of wt sin b, means sin alpha. Then we take the constant term outside the Laplace and separate by linearity property. Therefore cos of alpha is constant. Laplace of sin omega t plus sin alpha is constant. Laplace of cos of omega t. Therefore cos alpha sin of, we know that Laplace of sin at, a divided by s square plus a square. Here a equal to w. Therefore w divided by s square plus w square plus sin alpha. Then we know that formula for cos of at, s divided by s square plus a square. Therefore we have s divided by s square plus a square, a equal to here w square. Then we simplify this, equal to w cos alpha plus s sin alpha divided by s square plus w square, which is the required transform of the function sin of Wt plus alpha. Then we take the next example. Sin square 2t. Find Laplace of sin square 2t. We know the formula for sin square theta, 1 minus cos 2 theta divided by 2. Formula for sin of 2 theta formula for sin theta 1 minus cos of 2 theta divided by 2. Therefore we find Laplace of sin 2t equal to, here the angle is twice, therefore we have 1 minus cos of 4t divided by 2 by this formula. Then we separate the Laplace of 1 minus Laplace of cos of 4t. Laplace of 1, we know that Laplace of 1 is given by 1 by s, and Laplace of cos 80, s divided by s square minus a square. Therefore s divided by s square plus 4 square 16. Then simplify this, 1 by 2 into, here we take the LCM, s into s square plus 16, then by cos s square plus 16 minus s square cancels, then 16 by 2 we have 8, therefore 8 divided by s into s square plus 16, which is the required transform of Laplace of sin 2t. Then we consider the next example. Find Laplace of sin cube 80. What is the formula of sin cube 80? Therefore, formula for sin cube 80 is given by 1 by 4 times Laplace of 3 sin 80 minus sin 380. Then we separate the Laplace of two functions by using the property of linearity transform and linearity property of Laplace transform. Therefore, Laplace of first term minus Laplace of second term. Therefore, 1 by 4 times Laplace of 3 sin 80 minus Laplace of sin 380 1 by 4 times 3 into Laplace of sin 80. We know Laplace of sin 80, that is a divided by s square plus a square minus Laplace of sin 380. Here a equal to 3a, therefore we have 3a divided by s square plus 3a square, that is 9a square. Now in the numerator 3a is a constant, therefore we take outside the bracket. Therefore we have 3a by 4 common from this. Therefore inside the bracket we have 1 upon s square plus a square minus 1 upon s square plus 9a square. Then we simplify by taking the LCM. 3a by 4, the LCM of this s square plus a square into s square plus 9a square. Then by taking the cross, s square plus 9a square minus s square minus a square. S square cancels. 9a square minus a square, we have 8a square. Therefore 3a by 4 into 8a square divided by s square plus a square into s square plus 9a square. Now here 4 2s are in the numerator, we have 3 into 2 6a cube. 6a cube divided by s square plus a square multiplied by s square plus 9a square, which is the required Laplace transform of the function sin cube at. The next example we find Laplace transform of cos h to the power 40, which is the hyperbolic function. We use the formula for this. We can write first Laplace of cos h 4t. We can write square of square cos h square t and square of this. Then we use the formula of cos h square t, which is given by 1 plus cos h 2t divided by 2. Therefore Laplace of 1 plus cos h 2t divided by 2 square of this. Then taking the square of this, a plus b whole square, a square plus twice ab plus b square, 1 by 2 square, 1 by 2, 1 by 4. Therefore 1 by 4 Laplace of a square, that is 1 plus twice of cos h 2t plus cos h square 2t. Now then we separate the Laplace transform of each function by linearity property. Therefore 1 by 4 into Laplace of 1. Before this we use the formula for cos h square 2t again. 1 plus 2 cos h 2t plus again formula for cos h square 2t, we have 1 plus cos h 4t divided by 2. Then we can write 1 by 4 times 1 plus 2 cos h 2t, here type Laplace, plus here 1 by 2 plus 1 by 2 cos h 4t. Therefore 1 by 4 times Laplace of, now we know 1 plus 1 by 2, 3 by 2 plus 2 cos h 2t plus 1 by 2 cos h 4t. Now I separate the Laplace transform by linearity property of Laplace transformation. Therefore 1 by 4 times 3 by 2 is constant, we have Laplace of 1. 2 is constant, therefore Laplace of cos h2t. 1 by 2 is constant, therefore 1 by 2 into Laplace of cos h4t. Then we use the formula. You know Laplace of 1, it is given by 1 by s. Therefore 1 by 4 into 3 by 2 into 1 plus 2 into the Laplace of hyperbolic function cos of h, you know the formula, a divided by s square minus a square. Here a equal to 2, a equal to, therefore 2 divided by s square minus a square, that is 2 square, 4 plus 1 by 2. Laplace of cos h4t is s divided by s square plus 4, so that is 16. Now you know that in Laplace of cos function there is s in the numerator. Therefore here s in the numerator, here also we get s in the numerator. Then we simplify this as Laplace of 1, it is given by 1 by s. Therefore simplifying, we have 3 divided by 8s plus 2 by 4, we have 1 by 2, s divided by 2 into s square minus 4 plus s divided by 8 into s square plus 16. Which is the required Laplace transform of the given function. What is the Laplace of cos h to the power 4t? It is sufficient for today. We will stop here. You remember the formula, list of formula, and try to solve some examples from the book. Solo Niru publication, Nagpur, with the authors Dr. T.M. Karde and others. Thank you.